Hi guys! Today we're going to look at how to add some simple obstacle resolution logic to enemies so they don't get stuck walking into each other. We'll also look at how the same logic can be used to have the enemies navigate around obstacles. We'll be adding this to the 2D top-down shooter series we've been building. You can download this project and all the others in the series by supporting us on Patreon. All the links you need can be found in the description. Okay, we'll start by adding a couple of enemies into the scene to demonstrate the problem we're going to solve. We'll navigate to the Prefabs folder in the project panel. Then we'll switch to the scene view and drag in 2 enemies. We'll position these next to each other. Then we'll rotate them to face each other. We'll set the one on the left to have a rotation of -90 on the z-axis. And we'll set the one on the right to have a rotation of 90 on the z-axis. We want the enemies to walk directly towards each other. However, we previously added logic to have the enemies randomly change direction. Let's go to the enemy movement script to temporarily disable this. We'll comment out the line that calls the random direction change method. Okay, let's save this and switch back to Unity to try it out. We can see the enemies collide and then get stuck walking into each other. Eventually they work themselves free, but it takes a while. We're going to improve this by having the enemies detect and avoid each other. The way we're going to do this is by using a method called CircleCast. This method allows us to cast a circle in a specific direction and get a list of all things the circle collides with. So we'll use this to cast a circle in the direction the enemy is facing. When it comes into contact with another enemy, it will give us information about the collision. One of the values it will give us is a normal vector, which tells us the direction of the surface we've collided with. We'll then rotate the enemy in the direction of this normal vector, turning it away from the collision. Okay, let's go to the enemy movement script to implement this. First of all, we'll add in some fields that we'll need for the circle cast. We'll add a serializable float field for the radius of the circle we want to cast. Then we'll add another serializable float field for the distance in front of the enemy we want to cast the circle. We also need a serializable field for the layer mask to be used when detecting collisions. A layer mask allows us to exclude certain objects from the collision detection. For example, we don't want the enemies to avoid the player, so we can put the player in its own layer and use the layer mask to ignore it. The final field we need to add is a private array to hold the results of the circle cast. This will be of type raycast_hit2d. We'll initialize this array in the awake method. We'll create it with a size of 10 so that it can hold the result of 10 collisions. Next, we'll create a new private method called handleObstacles. We'll call this method from the updateTargetDirection method just after we target the player. Inside the new method, the first thing we'll do is create a contact filter 2D. Then we'll set the layer mask of the filter to the value of the obstacle layer mask field. We'll use this filter when we do the CircleCast to only detect collisions with objects on the specified layers. To do the cast, we'll do Physics2D.CircleCast. We'll pass in the position of the enemy as the start position for the cast. Then we'll pass in the desired radius of the circle. We want the circle to be cast in the direction the enemy is facing. This can be determined from the up direction of the transform. Next, we'll pass in the filter we created. Then we'll pass in the collisions array to hold the results. The final parameter we need to pass in is the distance we want to cast the circle. So this will cast a circle in the direction of the enemy and populate the array with all the collisions it encounters. The method returns the number of collisions, which we'll store in a variable. Then we'll create a for loop to loop through the number of collisions. We'll get the collision at the current loop index and assign it to a variable. Before we go any further, we need to check this isn't a collision with ourselves. We can do this by checking if the game object of the collider we've collided with is the same as our game object. If it is, we'll continue to the next value in the loop. Now we have a collision that we want to try to avoid. The simplest thing we can do is to set the target direction of the enemy to the normal direction of the collision. This will make the enemy turn in the opposite direction to the collision. We're just going to take action on one collision, so after this we can break out of the loop. OK, let's save this and switch back to Unity. We'll select the player in the hierarchy. If we look in the inspector, we can see that the player is in the default layer. We're going to put it in its own layer so we can exclude it from the obstacle detection. We'll click the drop-down and select Add Layer. Then we'll add a layer for the player. We'll select the player in the hierarchy again. Then we'll assign it to the new layer. When prompted, we'll choose to change all the children as well. Next, we'll set the obstacle detection settings for the enemy. We'll go to the Prefabs folder and select the enemy prefab. We'll set the radius to 0.45 to match the radius of the collider on the enemy. For the distance, we'll go with 1 meter. And in the layer mask, we'll select the default layer, which no longer contains the player. OK, let's press play to try this out. Now the enemies avoid each other. It's a bit extreme having them completely turn around though. Let's stop the game and switch back to the script to look at how we can improve this. At the moment, we're just setting the desired target direction to the normal direction of the collision. Instead, we'll gradually rotate the target direction towards the collision normal until the collision is avoided. We'll use the quaternion look rotation method to create a rotation looking in the desired direction. The first parameter is the desired forward direction, which isn't really relevant when making 2D games. We'll just pass in transform.forward to keep it at the current value. Then we'll pass in the normal vector of the collision for the desired up direction. Next, we'll use the quaternion rotate towards method to rotate towards this over time. We'll pass in the current rotation of the transform as the start rotation, and we'll pass in the target rotation as the target. For the number of degrees to rotate, we'll use the rotation speed multiplied by time.delta time. So this will give us a rotation object that will gradually turn to face away from the collision. We'll then use this to calculate the desired target direction of the enemy. We'll multiply the rotation with the default up direction to give us an up direction rotated by the desired amount. Once the enemy has rotated enough for the CircleCast to not pick up this collision, it won't execute this code and the rotation will stop. This will result in the enemy rotating just enough. Okay, let's save this and try it out. Now the obstacle avoidance is looking much better. Let's stop the game and set up another scenario. We'll go to the prefabs folder and drag another enemy onto the scene. We'll position and rotate all three so they face each other in a triangle. Now let's press play to see what happens. The enemies get stuck. That's because there are now multiple obstacles. Each enemy starts to turn away from one, then it tries to turn away from the other, and the two cancel each other out. Let's stop the game and switch back to the script to fix this. What we're going to do is add a cooldown period so we don't keep changing directions too often. We'll add a private float field for the cooldown time. We'll also add a vector2 field to keep track of the obstacle avoidance target direction. Then, in the handle obstacles method, we'll decrease the cooldown by time.delta time. Inside the loop, we'll now check if the cooldown value is less or equal to 0. If it is, the cooldown has expired and we can change the target direction. We'll store the normal of the collision in the new field we added. We'll also reset the cooldown to half a second so that we don't change this again until then. Then, in the calculation for the target rotation, we'll replace the collision normal with the stored target direction. So this will now keep the rotation consistent for half a second before recalculating. This should help reduce the chances of multiple collisions conflicting with each other. Let's save this and switch back to Unity to try this out. Now the enemies manage to get around each other. The next thing we'll do is see if this new logic works for other obstacles like walls. We'll delete 2 of the 3 enemies. Then we'll click the plus button on the hierarchy and add an empty game object. We'll call this wall. Then we'll right-click this to add a child object and select 2D Object, Sprites, Square. We can't see the square at the moment because it's hidden behind everything else. We can make it visible by changing the sorting layer. We won't create a new layer for walls though, as we're not going to leave them in the game. We'll just set it to the enemy layer to make it visible. We'll make the wall bigger by setting the scale on the y-axis to 5. Then we'll select the parent wall object and position it to the left of the player. We also need to add a collider to this object so that it detects collisions. We'll click the Add Component button and search for Box Collider 2D. We'll set the size of the collider to 5 on the y-axis to match the size of the wall. Then we'll move the enemy to the left of the wall so that it has to get around the wall to get to the player. OK, let's try this out. The enemy now navigates around the wall to get to the player. The final thing to do is remove the things we added for testing and try it out for real. Let's stop the game and delete the wall and the enemy. Then we'll go back to the script and uncomment the line that calls the random direction change method. Let's save this and switch back to Unity to try it out. We'll play the game until there are a few more enemies around. They now all seem to be doing a pretty good job of avoiding each other. In the next video in this series, we'll add a new zombie type that is bigger and stronger but moves more slowly. To do this, we'll make use of scriptable objects to define the attributes of the zombies. If you want to be alerted when this one's out, then subscribe and click the bell icon. If you have any questions or feedback on this video, let us know in the comments. A big thank you to all our patrons. We really appreciate you helping to support the channel. If you'd like to help and also get access to the source code, you can find details in the description. Thanks, guys.